rule. Generalize the rule. Markovnikov's rule. Markovnikov's rule. The rule states that when there is addition between an unsymmetric alkene and unsymmetric addendum, so addition between, there is a addition between unsymmetric alkene, unsymmetric alkene and unsymmetric addendum. Both are unsymmetric addendum. Then the negative part of the addendum goes to the less hydrogenated carbon. During this type of addition reaction, the negative part of the addendum, is added to less hydrogenated carbon. That means the carbon atom containing less number of hydrogen atoms. So, addition between unsymmetric alkene is unsymmetric, and the addendum, the molecule added, that is also unsymmetric. During the addition, the negative part of the addendum is added to the carbon containing less number of hydrogen atoms. So the positive part is added to the carbon having more number of hydrogen atoms. Negative part of the addendum is added to the carbon containing less number of hydrogen atoms. So the positive part of the addendum is added to the carbon having more number of hydrogen atoms. That is the rule, the Markovnikov's rule. Now let us apply this rule in the case of the addition reaction between propane, CH3, CH, double bond CH2, propane, and HBr or HCl or HI. Then what will be the main product obtained? We have seen there are possibilities for the formation of two products. Say this molecule, the alkene, is unsymmetric. Unsymmetric in the sense, if you divide the molecule across the double bond, the two parts obtained are not identical. That is what is meant by unsymmetric alkene. If the alkene is divided at the double bond, the two parts obtained will not be identical. That is an unsymmetric alkene. Suppose propane, this compound propane, if a propane is divided along the double bond, one part will be CH3, and other part will be CH2. So the two parts are not identical, and such a molecule is unsymmetric alkene. Unsymmetric. Similarly, the addendum is HBr, and it splits like this, H plus and Br minus. When the addendum ionizes, dissociates, the two parts obtained are not identical. So that is also unsymmetric. So Markovnikov's rule comes into play when there is addition reaction between unsymmetric alkene and unsymmetric addendum. And say you take on the other hand, you take this one, CH2 double bond to CH2. Now if you divide this molecule at the double bond, the 2 parts are equal, CH2 and CH2. The 2 halves are equal, so it is symmetrical. This alkene is a symmetrical alkene. Similarly, you take the reaction between this one and hydrogen. Suppose hydrogen is added. Then the addendum is split like this. We get 2 hydrogen atoms. The 2 parts are identical. So the addendum is also symmetric. Similarly, you take bromine, say bromine, it splits like this. The 2 parts obtained are identical. And so that is also symmetric. So there is no choice. There is no choice when there is addition reaction between symmetric alkene and symmetric addendum. There is no problem. We can add any part to any carbon, any part of the addendum to any part of the alkene or carbon. The product will be the same. But if the addendum is unsymmetric, similarly the alkene is also unsymmetric, then the products obtained will be entirely different. Say you take a CH3, CH, single bond CH2, the pi bond is broken. Then second case, CH3, CH, CH2, the double bond is broken. Now you add H plus and Br minus. Suppose you add H plus positive part of the addendum to this carbon and Br to this one, or vice versa. Br to the middle carbon and H to the first carbon. So 2 ways of addition, and which will be the major product. According to Markovnikov's rule, the negative part of the addendum, that is Br minus, is added to the carbon containing less number of hydrogen atoms, less hydrogenated carbon. That means the carbon containing fewer number of hydrogen atoms. So to that carbon, the negative part is added. Br is added. And the positive part, that is H plus, is added to more hydrogenated carbon, that is a CH2 carbon. So the major product will be this one. This is the major product according to Markovnikov's rule. The negative part, Br minus, goes to the carbon containing less number of hydrogen atoms, and the positive part, H plus, that goes to the carbon containing more number of hydrogen atoms. So the second product, that is the major product according to Markovnikov's rule. And this compound is, say, 1, 2, 3. So 2 bromo, 2 bromo, 2 bromo, 1, 2, 3 carbon atoms, propane, 2 bromo, propane, and this is the major product obtained. Next year, we have to see the application of this Markovnikov's rule. In many cases, we have to see this. Okay. So, when there is addition between unsymmetric alkene and unsymmetric addendum, the negative part is attached to the carbon having less number of hydrogen atoms. And the positive part is added to the carbon containing more number of hydrogen atoms. And that is our Markovnikov's rule. And according to that rule, say this compound CH3, CHBr, CH2, CH3, CH3, CHBr, CH3, CH2H is CH3, or a 2-bromopropane. That is the major product according to Markovnikov's rule. Okay. Similarly, suppose there is an addition with a HCl, or there is addition with a HI, then the chlorine is added to the middle carbon, iodine is added to the middle carbon, and hydrogen is added to the end carbon, just like a HBr addition. Okay, so that is about Markovnikov's rule. Suppose there is addition between unsymmetric alkene and HBr, only HBr, in presence of a peroxide. There is a peroxide as the catalyst. Then the addition occurs contrary to Markovnikov's rule. If there is addition with a HBr, only for HBr, not applicable to HCl, not applicable to HI, only applicable to HBr. So if there is addition with the HBr in presence of an organic peroxide, then the addition occurs against Markovnikov's rule, and that is called the peroxide effect. It is called the peroxide effect, or it is called a Karash effect. It was studied by Karash. So it is called the Karash effect. Name of the scientist Karash. K-H-A-R-A-S-C-H. Karash effect. And this is the anti-Markovnikov addition also. Anti-Markovnikov addition. So the Karash effect or the peroxide effect or anti-Markovnikov addition takes place when there is addition with the HBr. Remember, only HBr in presence of a peroxide. Then the product obtained will be contrary to the Markovnikov addition. That means the negative part goes to the carbon containing more number of hydrogen atoms, and the positive part goes to the less hydrogenated carbon. Say that is what when there is addition of HBr in presence of peroxide. If there is no peroxide, normal Markovnikov addition takes place. But if there is addition with the HBr, I repeat this, only with the HBr, the peroxide effect is seen only with the HBr. Karash effect is seen only with the HBr. Anti-Markovnikov addition only with the HBr in presence of peroxide. In presence of a peroxide. If there is no peroxide, there is normal addition, and we will get say 2-bromopropane as the major product. That is the Markovnikov product. But if the reaction occurs in presence of, say, bear in mind, the Markovnikov product is 2-bromopropane. But CH3, CH, double bond CH2, and HBr, only for HBr, plus, minus. And there is addition in presence of a peroxide, an organic peroxide, benzoyl peroxide, so tertiary butyl peroxide, in general peroxide, then anti-Marconic of addition takes place. That is CH3, CH single bond, CH2, the pi bond is broken, and the negative part goes to the carbon containing more number of hydrogen atoms, contrary to Markovnikov's rule. So, bromine will be attached to this carbon, first carbon, and hydrogen to the middle carbon. So, the product will be CH3, CH2, CH2, Br. And the compound is 1 bromo propane, 1 bromo propane, and that is the anti-Markovnikov addition product. And this happens only when there is a peroxide in the reaction mixture. It was studied by Karash, and so it is called the Karash effect, or it is the peroxide effect. Okay. So normally the negative part is added to the carbon containing less number of hydrogen. Positive part is added to carbon containing more number of hydrogen. That is normal Markovnikov addition. But if there is addition with the HBr, I repeat this, only with the HBr, not applicable to H2O, not applicable to HCl, not applicable to HI. You take any of these compounds. It was not studied. It is seen only in the case of HBr. In presence of peroxide, the anti-Markovnikov product is the major product. And it is called the peroxide effect or Karash effect. So that is the first reaction, addition with HX. Then Markovnikov's rule comes into play. Now, second one is called ozonolysis. Ozonolysis. It's a very important reaction. Ozonolysis. We have to use ozonolysis a number of times second year. Ozonolysis for the preparation of say a number of compounds. Ozonolysis is applied. And what is meant by ozonolysis? In ozonolysis, there are two steps. First step is addition with the ozone, O3 ozone. Then you will get an ozonide. An ozonide is formed. Second step, the ozonide is decomposed by water in presence of zinc. Zinc and water, the ozonide decomposes, giving either aldehyde or ketone. You'll get either aldehyde or ketone. Aldehyde or ketone is obtained. Aldehydes and ketones are collectively known as carbonyl compounds. Carbonyl compounds. So there will be formation of carbonyl compounds. See, there are two steps. The first addition with the ozone. Second, the decomposition of the ozonide with the zinc and water. Then we get an aldehyde or ketone. And how does the reaction occur? See, it is like this. C double bond C. This is our alkene. And this is made to react with the ozone first. Second, it is decomposed by zinc and water. Then the molecule splits like, see, at the double bond. And oxygen atoms are added on both sides. On both sides, oxygen atoms are added. So you'll get either an aldehyde or ketone. In general, C double bond O, that is carbonyl compound. We get we get the product as C double bond O, C double bond O. The other product also, say C double bond O. We'll get say two products, maybe the same or different. Let us see what it is. So the molecule is broken. It is cleaved at the double bond, and oxygen atoms are added to both sides. So that you'll get either aldehyde or ketone, and the reaction is called ozonolysis. Next year, we have to study the preparation of aldehydes and ketones. And this is one of the important methods for the preparation of aldehydes and ketones or carbonyl compounds. So, for the preparation of the carbonyl compounds, that is aldehydes or ketones, we can make use of ozonolysis of alkenes. Ozonolysis of alkenes. There are two steps in ozonolysis. First, the addition with ozone to form an ozonide. Second, the decomposition of the ozonide with the zinc and water. Then you get aldehyde or ketone. When aldehyde and ketone is formed, ultimately what happens? Ultimately, the compound is cleaved at the double bond, and oxygen atoms are added to both sides, so that we get a C double bond O, a compound containing C double bond O group. And the compounds containing C double bond O group are called carbonyl compounds. So are called carbonyl compounds. So that is a general reaction. Let us take, for example, CH2 double bond CH2. That's our ethane or ethylene. And this is subjected to ozonolysis. That is, first it is made to react with ozone. Second, it is hydrolyzed or decomposed with the zinc and say water, zinc and water. What I told you is this: the compound breaks. The compound breaks at the double bond, and oxygen atoms are added to both sides. We get the same product: CH2O, CH2O, CH2 double bond O, two molecules of a CH2O. And what is CH2O? It is H, C double bond O, H, and it is a CH2O. The compound contains a CO group, so it is a carbonyl compound. It contains a CHO group. There is a CHO group, and so it is an aldehyde. That is an aldehyde. Aldehyde is formed. And this aldehyde, HCHO or a CH2O, that aldehyde is called foam aldehyde. It is a foam aldehyde. And in the IUPAC nomenclature, it is known as methanol. Methanol. So during ozonolysis of ethane, we get only one product, and it is a methanol or a formaldehyde. Okay, let us take another compound, say like this: propane, CH3, CH double bond CH2, take propane, and propane is undergoing ozonolysis. That is, one, addition with ozone. Second, decomposition of the ozonide with zinc and water. Then what will be the ultimate product obtained? Say the ultimate product will be this. The compound is broken here, and oxygen atoms are added to both sides. Oxygen atoms, that is the common reaction. The oxygen atoms are added to both sides. You get a CH3, CH double bond O, plus other one, CH2 double bond O. So first compound, that's an aldehyde. CH3, C double bond O, H. The other one you know, H, C double bond O, H. So we get a mixture of aldehydes. The first compound is called acetaldehyde. This is a acetaldehyde. And in the IUPAC system, acetaldehyde is known as 1, 2, 2 carbon atoms. So it is ethanol. Ethan, all for aldehyde. The other compound, it is methanol or a formaldehyde. So we get a mixture of aldehydes. A mixture of aldehydes will be obtained. Suppose you take another example, say CH3 bond CH, double bond CH, single bond CH3, and it is butene. So but2ene. The double bond begins from the second carbon, and this undergoes ozonolysis. Ozonolysis. Say what will be the product obtained? Can you say now? CH3CHO. The compound breaks at the carbon-carbon double bond, and you will get CH3CHO. Only one product is obtained. Only one product. So 2 molecules of CH3CHO. That is our acetaldehyde or ethanol is obtained. So addition with the ozone followed by decomposition of the ozonide with zinc and water. That is called ozonolysis. And the net reaction is this. The net reaction is the breaking down of the alkene at the double bond, and oxygen atoms are added to both sides. Suppose you take a compound like this, CH2, double bond CH, CH2, CH3. Now, this is undergoing ozonolysis. Can you expect? Can you guess what are the products obtained? Just try. You try. Right or wrong, it doesn't matter. Just try. What will be the products obtained? What you have to do? You simply break the compound at the double bond and add oxygen to both sides. That is the product. If it is so, what will be the products obtained? See, the compound breaks here, see here, and oxygen atoms are added to both sides. So you'll get CH2O plus. The other compound is the CH3, CH2, CHO. CH3, CH2, CHO, or CHO, CH2, CH3. CH3, CH2, CHO. We get a mixture of aldehydes. The first one, CH2O, that is our methanol or a formaldehyde. And the second one, it is propionaldehyde or propanol. Propanol. It is a propanol. Propane. From that we have propanol. Propanol. We get a mixture of aldehydes. And that is the addition of ozone followed by decomposition. The ozonide with the zinc and water. We get a mixture of carbonyl compounds. From the carbonyl compounds, we can decide which is the alkene used. Okay. That's about ozonolysis. Now you come to the third reaction. That is the decolorization of a Bayer's reagent. Decolorization of Bayer's reagent. Bayer's reagent. Do you remember this reaction? Bayer's test for unsaturation. Bayer's test for unsaturation. What is Bayer's reagent? Bayer's reagent is an alkaline solution of dilute potassium permanganate, that is pink in color. So, dilute KMnO4 potassium permanganate in presence of an alkali, for example, KOH. And this is pink or violet. Pink or violet in color. And that is the Bayer's reagent. So Bayer's reagent is pink colored, violet colored, called dilute alkaline potassium permanganate. When potassium permanganate is added, called dilute alkaline potassium permanganate is added, Bayer's reagent is added, there is sudden decolorization by the unsaturated compounds, alkenes. Say, for example, CH2 double bond CH2. Then what will be the net reaction during decolorization? There is a addition of H2O and oxygen. H2O and oxygen. It's a common reaction. See, the double bond, say, the pi bond is broken. Pi bond is broken. And OH groups are added. OH groups are added to the two carbon atoms. So a compound containing OH, that is all, alcohol, all. Here there are two OH groups, so this is a diol. It is a diol. The two OH groups are on the neighborhood, and so they are called vicinal. Say vicinal diol. Vicinal diol is formed. Vicinal, vicinity, neighborhood. Vicinity, neighborhood. They are good neighbors, unlike us. The two carbon atoms are good neighbors, unlike us. Okay, so there is no problem because both are getting OH groups. Both are getting OH groups. The pi bond is broken and OH groups are added. Hydroxylation. OH group is added. It is a hydroxylation. We get a vicinal diol. And this vicinal diol, that is called glycol. And this glycol is of ethylene or ethene. And so it is called ethene glycol or ethylene glycol. Ethane glycol or ethylene glycol. Ethane glycol or ethylene glycol. We get this vicinal diols. So a very common reaction during the decolorization of permanganate. The pi bond is broken and two OH groups are added to the neighboring carbon atoms. And it is a vicinal diol. Vicinal, the short form is VIC, vis. VIC, vis. Vis for vicinal, neighboring. So vicinal diols. And the vicinal diols are called glycols. They are called glycols. And this glycol is of ethene or ethylene. Sorry, ethene or ethylene. And so the glycol is ethylene glycol or ethane glycol. There is an addition of two OH groups. And it is the hydroxylation reaction. Hydroxylation reaction. We have to see one more reaction, and it is a polymerization reaction. Polymerization. At what time I have to stop? Is it a time to stop? Is it? See, at what time? Okay. So there is one more reaction. It is a polymerization. It is a polymerization reaction. And what's meant by polymerization? Polymerization. Say polymerization means that is the last reaction here for polymerization. We need this also for the second year. Polymerization. Poly means more than one, many. Poly, many. Meros means parts. So many parts are combining together to form a large single product. It is called a polymerization. So polymerization is A combination of a large number of small units. Combination of a large number of small units. Small units. Small units means small molecules of the same type or different type. It doesn't matter. There is a combination of a large number of small units to form a large molecule. To form a large molecule, or say a macromolecule. Macro means large. A large molecule or a macro molecule, and that reaction is called a polymerization reaction. It's a combination of a large number of small units. Large number of small units to form a large molecule or a macromolecule. The large molecule is called the polymer. It is called the polymer. And the small units are called monomers. Monomer. The monomer may be the same type or different types also. More details we can see second year. So there is combination of a large number of small units, combination of a large number of small molecules to form a macromolecule or a large molecule. That is called a polymerization. The large molecule or the macromolecule is called the polymer, and the small units, they are called the monomers. Mono means single. One monomer. Let us take the polymerization of ethene. CH2 double bond CH2. Ethene or ethylene. When ethane polymerizes in presence of traces of oxygen as catalyst at a high pressure and high temperature. High pressure and high temperature. A large number of ethene molecules are combined together. The pi bond is broken. Say CH2 single bond CH2. Pi bond is broken, and the ethene molecules are joined one after the other, are combined one after the other. So we can write it as CH2 single bond CH2N types, the polymer. See, it is like this. The polymerization, it is like this. CH2 single bond CH2, one molecule. CH2, second molecule. CH2, third molecule. See, the combination of a large number of ethene molecules forming a very large molecule, and the large molecule is called a polymer, and this polymer is called it's a very familiar compound. It is our polythene. Do you know polythene? Plastic. Polythene bucket, polythene mug, polythene sheet, polythene plastic. Say ethene gas. Ethene is a gas. We may feel that it's of no use, but when it undergoes polymerization in presence of traces of oxygen, or there can be peroxide also as the catalyst at high temperature and pressure, then N molecules. N will be variable number of the ethene molecules. The pi bond is broken, and ethene molecules are added one after the other, just like the coupling of the different compartments in a train. Say in a train, passenger train or goods train, whatever it is, there are, say, a large number of bogies are coupled together, joined together to form say a large train. Similarly, here also there is the coupling or the combination of a large number of small units to form a macromolecule, a macromolecule or a large molecule. And when ethene or ethylene undergoes polymerization, we get the plastic material, namely polythene or polyethylene. Polythene or polyethylene. So this type of reaction is called a polymerization reaction. Okay. So I have taken only 4 important reactions of alkenes. So you must study at least